let's make sure you're all up to par on this. Could everybody do these? You tell me where the questions are. When you take the square root, again, make sure you give me a plus or minus. As soon as you see plus or minus, 2 quadrants are negative, 2 are positive, you have all 4 quadrants. Find your reference angle just for the first one. Then that goes into 180, do this. You can find all of them that way. Did I ask you to find it into 4 pi or all solutions? 2 pi. Okay, so if you're only looking for 2 pi, you're going right here. If you're doing any solution, because these are opposite through the origin, they're 180 degrees apart. Every time I go 180, I hit the next one, so you just have to do this one and this one with plus n pi.
That's for any solution?
That's for any solution.
The other one is for find all solutions.
This is for all from 0 just to 2 pi. That's your direction set?
Yeah.
Okay.
So if it says 0 to 2 pi, you don't have to have the word.
You don't have to have this. But if that's the way you want to start and then just continue it, like you could say, okay, let me add n pi, which is 4 pi over 4, 4 pi over 4. So then it would give me pi over 4. It would give me 5 pi over 4, and I wouldn't have to look at that, depending on what you want to do. It all works out the same. I think it's just easier within 4 pi just to do it right on the grid. If it's more than that, then I wouldn't. Like today's, when we do multiple angles, no. Again, tangent, you could do your sum of your squares, your perfect squares. Tangent x plus 1, tangent x minus 1, it all works out the same. Find your reference angle again, it's a plus or minus. Remember, the tangent of 1 is 45. That one doesn't have a quadrant angle. Okay, so again, we got the same angles, same 45-degree angles, same answer as the last one. Okay. Stop me if you have any questions. Yep.
When do you put the 2 and pi, which is
2 and pi is when sine and cosine. What happens to sine and cosine? Like sine, for instance, is positive here and here. They're not in the same, they're not opposite each other. Only tangent and cotangent are. So sine, if I do this angle, if I add 180, it's going to bring me down here. So this one I have to come back to 2 pi. This one I have to come back to 2 pi. Because they're next to each other. If it's across the pole, across the origin, then you can do the 180, the plus. In this case, when it's all 4 quadrants, definitely. If you did all 4 and say plus 2 n pi, it's not wrong. It's not wrong, but there's a shortcut.
the 2 and pi is when they're across from each other?
The 2 n pi is when they're not through the pole.
Yeah.
Yes. Like sine and cosine sit next to each other all the time. Okay, this guy, this is like if you did x, if you struggle with this, put an x. X cubed equals x. Can we ever divide by an x, divide by a variable? No, you get it to one side, and then you factor. So get your cosine to one side and factor. Your rules of math don't change. You can never divide by your variable and get rid of it. So pull it to one side, factor it. This is your goal. If it helps you, just go like this. This is your goal to get 2 sections. This one you could do perfect squares, so you could add 1 and take the square root. Same difference. So you get your plus or minus 1. Remember, zeros and ones are quadrantal angles, and these are all solutions, no restrictions. If you do this in your calculator, you're only going to get one answer. When you do this, you're going to get a 90 degree. You'll never get the 270. So you need to know that you're doing all 4 quadrants. And from 0 to 2 pi, you hit them all. Which makes sense, right? It's either going to be a 1, a negative 1, or a 0 for the x value. So you hit them all. Doesn't that make sense when you think about it? Probably factoring is the hardest part because it's always a little bit more difficult to look at it with a sine and a cosine in it.
When you solve the original thing, will you ever get numbers that aren't like on the unit circle?
You can. But then, you know, like this is a quadrant angle, but you know, like when you do a triangle and you drop a triangle and we found it was 45, if you found one that was not on the unit circle, you would just have to do, like, find the reference angle, second sign, find that angle, and then figure it out all the way around. God bless you. Probably in degrees. Like, in other words, what Lily's asking is this. Let me look at the next one. It's true. Probably the quadrant angles don't work that way, but say you came down. Okay, say you came down to this triangle over here, and this didn't work out to be a special triangle, and they don't always have to work out to be a special triangle. So what you would have to do is find out what is this reference angle. So say this side came to be, say it was a 3 and a 4 and a 5, right? So if I look up to find this reference angle, I can just do like second hand. What is 3/4? I can find this reference angle. Then I can find this angle, and I can find this angle using that reference angle. I'll probably have to round it somewhere, probably put it in degrees, make it easier than putting it in radians. But it has the same process. The special triangles just work nicer. Generally, we use the special ones, but you might see one on the homework that doesn't. But it works the same way. This one has a little bit more work because if you notice, you have two different functions. So these are two different variables. The only one I can change is a sine squared. I can't change a cosine. I can use Pythagorean's identity and solve for sine squared in terms of cosine and replace it, substitute it out. That's the one identity that you have to memorize. And again, you can find this off of your unit circle. When you do this, this is a 1, this is your x, this is your y. This is Pythagorean's theorem. Replace this with the cosine, replace this with the sine. That is your Pythagorean identity.
How did you get rid of the sign?
We had to use Pythagorean's identity to get rid of the sine squared. We can't get rid of the cosine, but we have one identity that we had to know. So if we solve for sine squared in terms of cosine, we could now take this out and substitute this in. And now everything is cosine. That's the one identity you have to know. You can do your secant, your tangent thing, right off of that. But that's the one you have to know. So replace that, be careful, and I see this, even though you're honor students, I see this a lot. Somebody will say minus 2, minus 2, minus 2. Doesn't work that way. You're on one side of the equal sign. So be careful of this part right here. That'll cancel out. Be careful of this negative because we don't want a negative when we first go to factor. Your first term of your highest exponent should be positive. Divide by a -1 and then factor. You've got cosine is negative and a cosine of 0. Question? That one takes a little bit more work. You can't replace the cosine because there it is, cosine squared. See, sine squared. Good? This is algebra right through here. All algebra right through there. And you only had to go from 0 to 2 pi again, the whole thing, 0 to 2 pi. Well, all the problems? Good. This one looks a little strange, but it works the same. This is a secant. This is a secant. It's like x squared minus x equals 2. So you've got an x squared and an x and a 2. Get everything to one side. It's a trinomial. Factor it as a trinomial. Again, like we did yesterday. Pull it to the side if you struggle. And factor this. Factor this first. If you like to do this, it works this way too. And then replace it. If you want to get all the way down to x is equal to 2, x is equal to negative 1, and then put the word secant in there, that works fine too. Remember secant? Its range goes from positive 1 up, negative 1 down. So you can have a negative 1, you can have a 2. If you hate working with the secant, take its reciprocal, work with the cosine. Some things are not so bad. I know this group is not fond of factoring for some reason. Okay.
What if you go like plus 2 and
Well, I only gave you from 0 to 2 pi to get solutions. So these are all I wanted. But if you did this, this would say pi over 3 plus 2n pi, because you have to go full circle. They're next to each other. So they're not across the origin. Someone has to say that as well. Good. Okay, the next one. It's got a lot of weird things in there. If you struggle with that, make the secant be x, make the cosecant be y, and start like this. I cannot divide by a variable. So you got to get this to one side. Oops. Sorry, minus. So then you're going to factor out a y. Do this through and figure out. Go that way. Replace this with your cosecant. Replace this with your secant. If you want to wait till the end to do it, that's fine too. Then replace this with your cosecant, if that's the one we took out. And replace this with your secant. Now your cosecant can never be 0, because your range is from 1 above to negative 1 below. It doesn't use where your sine uses, right? So this can't happen. This part is a reject. Cosecant 1/2. So cosecant 2. If you want to look at the cosine, flip it over. Cosine 1/2. If you had to do all solutions, these are both plus 2n pi. X equals. I tend to use theta, don't ask me why. I don't know why. I hate when they use x.
When you draw the angles, that's just because it's cosine and it's like a shift to that.
You can leave this here. Cosine is the reciprocal, so if you want to do it this way, that's fine. You don't have to flip it. But if you don't like looking at the secant, flip it to cosine.
No, I mean like when you drew the angles, like the pauses that you put it in, that's just
Because cosine is positive. The x is positive. You just say secant uses which one, x or y? It uses the x. So where is x positive? Go to the x-axis. Wherever the x-axis is positive, the secant and the cosine have to be positive. That's why you have to be familiar with the cosecant. Uses the y, the secant uses the x. Alright. This one's a little strange because I can't replace the sign.
Yeah, I looked at the notes.
Well, but use what you know. So when you're stuck here, I see this, right? And I say 2 sine x plus cosecant x. They're two different variables. If I rewrote this, this is like 2y plus x. I need something to substitute out, right? I need another equation, which is when you guys give Pythagorean's theorem. You do the Pythagorean identity, but this doesn't have a square. So what else do these guys have in common, sine and cosecant? They're reciprocals. So replace this with its reciprocal. everything say sine now? Yeah. And yes, it has a fraction. Just multiply every term by sine of x. Multiply this guy by sine of x, this guy by sine of x, this guy by sine of x. This now becomes 2 sine times sine is sine squared. This guy is wiped out, and this guy is a 0. Okay. This one, when you get to that point, when you have to take the square root of a negative number, you can't. So, no solution. Reject, reject. Okay. Use what you know. I'm sure you planned with the next one too, right?
No, I actually got that. I think.
You did Pythagorean theorem with that one, the identity? Good.
I don't know.
Is this the last one?
Yeah.
All right. So remember, I said there's only one you have to remember, and that's this guy. Cosine squared plus sine squared equals 1. What do I have to divide by to get me a tangent? Tangent is what? Sine over cosine, right? I need this to be over cosine. So, I must have to divide everybody by cosine squared. It all works off of this one identity. This becomes 1 plus tangent squared equals secant squared. Right? It's kind of nice. I could replace the secant squared, which makes my life easier because it's already set up for that, right? So I could replace the tangent squared if I want to just move that around a little bit. But since it's already set up, I'll just take the secant out and replace it with 1 plus the tangent squared. Now everything's a tangent. I could do it the other way, but then I just have to manipulate that a little bit. Remember, you're again on one side of the equal sign. No matter how many times I say it, I get kids that still do this. So this is your highest level, your next level, then your minus 1. Oh, they're both squared, sorry. 2 tangent squared and 1 tangent squared gives me 3 tangent squared. Minus 1, move it over, divide by 3, take the square root. Remember, the square root of 1 is 1.
Did you get the plus 2?
The plus 2? Because it had a 2 out here. So did you distribute this 2? You have to distribute that 2 because you're only replacing, you're substituting out secant squared. So you got to distribute this first, and you're on one side of the equal sign. What is a 2 minus 3? That's your negative 1. Don't forget to distribute that. And your plus or minus, all quadrants. Another thing I see kids do is leave this under here. If you leave that under there, it doesn't look like anything that you know. Separate those. Square root of 1 is 1. So, a 1 and a radical 3, that says, I know that special right triangle. 1 radical 3, 2. I know that one. You have to just manipulate.
1 minus cosine squared adds sine.
I can't because you want me to substitute this.
Yeah, what if you did the thingy and then
Wait, but if you take the square root of all of them, the square root of 1 is 1.
You can't take the square root of that.
No,
No, I'm saying like.
You can't take the square root of that either.
No,
You can't take the square root of individual terms.
no, like cosine squared x and sine squared x equals 1, and you take the square root.
You can't take the square root of that. Because the cosine squared, can I do this?
So plus,
Can I take the square root of this?
Yeah.
What would that answer be?
x plus y equals
So you're telling me I have 2 factors of x plus y.
okay, never mind.
Right.
Oh yeah, you right.
Oh yeah.
Never thought about it.
So, we're on the right track here. But we can't, we gotta work on this. I gotta get sine to say sine squared. So how can I do that? I may not be able to take the square root of both sides, but I can take the square of both sides.
And then you plug in.
But. This is nice. It becomes sine squared. Okay, does this become cosine squared plus 1? No, we gotta FOIL that out. So cosine squared plus 1 cosine plus 2 cosine plus 1, if I'm just taking a shortcut here. Are you okay with the plus 2 cosine? You got to do this. It's like x plus 1 times x plus 1. Don't you get x squared plus 2x plus 1, right? Now I can take this out and replace this with this. Okay, now I can get everything to one side. I got descending variables. Remember, you can't divide by anything. So I'm going to take out my negative 1 first. Just get rid of the 1s. And I'm going to add my cosine squared to this side. I have to put it under cosine squared. So we should be there, right? We were here. I replaced that. I have to move everything to one side, so don't you have to subtract the 1 so the 1s come out. You have to take the opposite. You have to add this, but it's a cosine squared. Make sure it goes under your cosine squared. Cosine squared plus cosine squared is 2 cosine squared. Now what do I do? I could divide by 2 if you like to, or you could take out a, what would you like me to take out? A 2 cosine? And what am I left with? I could do that. I could have divided by 2 first and got rid of that, because this 2 doesn't matter, right? Because once I set this up, my 2 is gone anyway, isn't it? Divide by 2 with a 0. So you could do it any way that you see fit. And then can you find me your answers from there? Of course. So they're quadrantal angles because they're zeros and ones. So my cosine curve goes from like this, from the zeros, from the negative 1 to the positive 1. So I know they're a quadrant angle. So I set this up. This is my x, this is my y. So in from 0 to 2 pi, where is my x value 0? God bless you. And where is my x value negative 1? Pi. So that's me. And remember your rules of math apply. No shortcuts in these. No shortcuts in these. Now, we think this looks good, but, remember when we used to have like radicals and we squared them, and we did like other things? It was the radicals that we squared, mostly our radicals, or the absolute values that we manipulated. We always had to go back and check to make sure we didn't have an extraneous root. You have to go back and check these guys. Now, it's not that bad. You go to your calculator and you put it on your calculator. So I'm just going to leave my mode in radians. I just need them to be equal. I don't care what it looks like. I just need them to be equal. All right.
Like the second.
I'm trying, but it's just not taking. My arrow is sitting here, and I couldn't get it to take this. So all you have to do is this. So let's put in the cosine of, say, pi. You might have to do this on your calculator, because my second doesn't want to work. Nope. All right, so you're going to do this on your calculator. And it doesn't matter what it looks like what the answer looks like, they just have to be equal to each other. So the one that you're going to find doesn't work is this guy. We have to reject this. Now, why do I know this would happen? Because I didn't divide by anything, I didn't do anything, I squared something. So if you square a negative, you get a positive. So there are situations where that might be a negative, and I forced it to be a positive. Kind of like when we squared your radicals on both sides, remember? Because then it wouldn't work underneath the radical.
What are we supposed to put in?
You're just supposed to take, say, cosine, say, like pi over 2 plus 1, hit enter. Sine pi over 2, hit enter. Those numbers should be the same, regardless of what they are. Then just try 3 pi over 2. Cosine of 3 pi over 2. So the cosine of 3 pi over 2 is 0. 0 plus 1 is 1. the sine of 3 pi over 2 is negative 1. See it? I'll do this algebraically. The cosine, let's do this. When I'm 3 pi over 2, the cosine here is 0. 0 plus 1 is 1. The sine of 3 pi over 2, is negative 1. So is that equal to each other? No. It will always be the negative ones that will give you grief.
What if you do like cosine?
You can just put it in radians and put your radian answer in there. It doesn't matter what your answer comes out to be, they just have to be the same there. Okay. So just a little thing to throw you off just a little. Now, here's the big one. Here's the big one. Multiple angles. So let's take a look at this equation. Let me move it up a little bit. Let's take a look at this equation and tell me what looks different than what we've been doing. Oh, it's a 3. Normally we say 2 cosine x minus 1 equals 0, right? It's a 3 in there now. This means this is a triple angle. Do you guys do double angles at all with those formulas? No. I take it you didn't do half angles.
No.
Okay. This means I'm going to have 3 times as many angles inside of that one angle thing. So let's take it one step at a time. So if I would do this, how would you solve this if x was just 1? Okay, we add 1, we divide by 2. Then we say, okay, where is my cosine positive? 1 and 4. So I say x there. I say, okay, I'm in business. So 60 goes in 3 times. So this is going to be 6 pi over 3. So I've got pi over 3, and I have a 5 pi over 3. Plus 2n pi, whatever. Now, if I make triple the amount of angles in here, triple the amount of angles, instead of getting 2 solutions, how many should I get? 6. So what we're going to do is, God bless you, we're going to solve this the exact same way. Don't panic. Just put a little line under this for now. We're going to solve it the exact same way. Then we're going to come down here and we're going to say, okay, you found my angles. You found me to be pi over 3 plus 2n pi. You found me to be 5 pi over 3 plus 2n pi. Just carry the 3 down with you. We did this part already, right? Now is where I'm going to solve for x. I got to get rid of this 3. So I'm going to, this is multiplied, opposite is divide. I'm going to divide everybody, it's an equation. I'm going to divide everybody by 3. So this is going to become x is equal to pi over 3 times 1/3. What are your rules of fractions? Keep, change, flip. Pi over 9. Sorry. That's a 9. Doesn't that make sense? Isn't 3 times 3, 9? So instead of getting pi over 3, I need pi over 9. I need 3 inside of that thing. But plus 2/3 2n pi over 3. Just leave it like this for now. You got to divide everybody. Then you're going to do the same down here. So this is going to give me x is equal to what? 5 pi over 9 plus 2n pi over 3. Okay, now think of this for 1 second. What is 2 pi over 3 in degrees? Like 120. Okay, so now 2 pi was how many degrees? 360. I got one of these angles in 360. I need triple the amount. So instead of going every 360, I went every 120. Isn't 360 divided by 3 every 120? It's harder to see in radians, I get it. but the concept is there. You need triple the amount of angles. So I should get, from 0 to 2 pi, I should get 3 angles. So if I'm going to go from 0 to 2 pi, see if we can just fit this in. I got to convert this to the same denominator. Everything has to be the same denominator if I want to add these, doesn't it? So my highest denominator right now is 9. So I'm going to go up to 18 pi over 9. That's how I know where to stop. I got to go from 0 to 2 pi. Agree? I should get not 2 angles, I should get 6 angles altogether. So I'm going to convert this guy to ninths because I got to be able to add them. So this goes in 3 times 2. This is 6 pi. This is 6 pi. So I'm going to start like this. Oops, that's pi over 9. I'm going to add 6 pi each time. So then I get 7 pi over 9. So then I get 13 pi over 9. So now if I add another 6 pi, I get 19 pi over 9. Aren't I outside of what I wanted? So I don't want this guy. And that works out nice. Instead of 1 angle, I got 3. I do the same here. I start with 5 pi over 9. I add 6. I add 6. If I add 6 again, aren't I past my 18 pi over 9? I only want to go to 2 pi. So now, did I have triple the amount of angles here? Yeah, I triple the amount of angles. That's the only difference. We're going to solve it the same exact way.
Good morning. This is just a reminder to all students before the bell rings that you are to walk with a purpose and get to your classes on time today. If you are, you will be brought into the auditorium, and there will be a consequence. Again, let's make sure that we are getting to our classes on time. Do not hang around in the hallways. Walk with a purpose. Thank you.